Hey guys, welcome to the third CAD workshop this semester. In this workshop, we're going to be finishing or talking about more advanced features in part modeling, and we will also work on assemblies in SolidWorks. And we're going to finish the practice exam that we started last workshop. And to start, to start this workshop, we're gonna start where we left off. So we left off at this stage. It was question number, let me see, question number 5. We finished modeling this part and we answered the questions and we answered it correctly. So now if we go to the next section, question number 6, we can see that now they are showing us a cross-sectional view of the part. And what it looks like is that they extruded cut material out of here and then some material from there, and they gave us the how it looks like from the front view. So if we look at here, it seems that we just have to cut this part, and to do so, well, we're gonna start with this face because it looks like it's on that face. Yes, so we go here, we go to sketch, and we're gonna sketch, go to normal view of the sketch, and so it looks like it's a bit dark right now because of the material that we added uh, to help with visualize and see what we're doing. We can uh, let's see, change the view over here. I think plain white. Yeah, I think that's good. I can see the lines and see all the edges and features. So if you look over here, it says, let me zoom in. Says 1 TYP, and 1 TYP, what it means is that it is one and then of the unit of the model. And if we look over here, we're using millimeters, grams and seconds, and if we click this button, we are in the same unit. So that is one thing that we have to keep in mind. And this whole thing just follows the contour of the outside portion, this like face. So to do so, to get the sketch lines as fast as possible and as accurate as possible, what we can do is use the convert entities tool. Basically, you can click this tool and you click on all the sides that you want to convert into sketch line or sketch entities, guys. And you can click on all of them, or yeah, just click the face. I think that'd be better. And we can click OK. So now if you can see, it basically just converted everything, the whole face into just sketch entities. And if we look in the model, we can see that um, the circle is not extruded, or like there's no border around the circle. So that means that when we extrude cut, we're not gonna keep the circle. So we will delete that line. To do so, we click trim entities and we click the left mouse button and we hold it and we drag the mouse button, and when you drag it, you're going to see this line, and whatever line or segment you touch, it'll delete it for you. So now we deleted this circle. There's no dark black line around it, meaning there's no sketch entity around it. And now we got this contour. Now what we want to do is now we want to offset all these lines inwards by 1 to get this shape, and to do so, instead of redrawing everything and moving all the lines independently, what we can do, we can use the offset tool. What we can do here is click the button, right? Select the how much distance what we want, and here it says 1, so this is what I'm going to say. I'm going to say 1 millimeter. And then what we can do now is just select all the features uh, that we want, and once I clicked all of them, if we zoom in a little bit, you'll see that the yellow line is basically projecting what this feature will do, and we can see that it's doing it outside. We want it to offset it to the inside. So what we can do is there's this button that says reverse. We click that button, and it reverses the feature to go inwards. And now we know that all these features have been moved inwards by 1 unit, which is millimeters in this part. We click OK. And now what we can see is we will still have the lines that we already originally had, and we have these new lines. So we will need to trim the entities, these outside lines that we don't need. So that's what we'll do. And you have to make sure that you get all these small lines. Oops. So I did an oopsie. So I undo. And I try to do this. Right. Okay. So now it highlighted it with blue, meaning there's no, this is a closed uh sketch, and that's what we want. And we deleted all the outside lines. And now to extrude cut, we go to features, extruded cut, and if you look at it from the side, what we want is, if you look at the model, we see that it extruded cut and until this feature, and oops, it it shows us, it doesn't tell us what's the distance here, but um looking at the model, we can assume that it's also this distance here is going to be the same distance between here and here, which is 1 unit. So what we can do to, instead of measuring this whole length and manually putting that value, what we can do is to extrude cut up to offset from surface, meaning we want to select a surface that we want to offset from. So it'll be this surface, right? Oops. And we will offset it by 1 millimeter, because this is the dimension that we use over here. We click enter, and if we look over here, it previews the feature in the yellow lines, and it looks correct to what we want. So we click OK. So now we got this part, and now to do the remaining section, this section, we'll use the same method. So we will select this face, go to sketch, and sketch it, and then go to normal to that sketch so we can see what we're doing. And we will use the convert entities again, and this time I'm not going to select the whole face, I'm just going to select the lines that we need. So I'll select this line, this line, this line, and this line. Wait, no, that's the face. So right click that, I'll say delete, and okay, the line. Okay, and now to get the feature, this line, what we can do is we can look at it from this other view. We can select this line, and now if you see, it adds it to this list. And um, and if we look over here, let me look at normal view one more time. Oh, I can't. Okay. So, and we can see that we got this line, this line, this line, but we did not get this line, and this arc needs that line to, have this a closed sketch. So what we will also select this line, and not the face, the line. There we go, and then we'll click OK. And then I'm gonna go to the normal view, and if we look at it, we can see that there's some certain lines that are exceeding what we want, and there are some that are yes. So what we do is, well, if we look at this picture, right, there's no incrementation like in the dimensions from this side to this side, meaning that we will not need to offset this. However, we will see that there is some sort of material between this curved feature and the extruded cut, so we will need to offset this feature inwards by 1. So we will use the same method of 1 second. But before we do that, let's just cut all the excess lines, just to keep everything, as clean as possible. So we will say, wait, first, oh, I exited out of the sketch. So I re-entered the sketch. I will first press trim. I want to trim this line, but not that line. Okay, so apparently it seems that I deselected this line, and that's why when I trimmed this, it trimmed the whole piece. So I'll have to go back to convert entities, select that line, and click OK. And now it converted it to line. We can see that it's dark black, solid black. So then we'll do the same thing here because it also seems there's no line over here. So we'll click Convert Entities, select that line, click OK. Okay, and now it does look like we have a solid uh, sketch. So now we will click the Trim Entities and we'll trim this small section. Uh, and we'll also trim this section out because this is one continuous arc. And we'll do the same thing here. We'll trim this piece out and then trim this piece off. And now we can see that it highlighted it, meaning it's a closed sketch. And now we have to offset this line uh, to, to keep this dimension the same. And to do so, we will just select that line, select the offset tool, select that line, and then one dimension is correct. It seems that's going to offset outside. We don't want that. We want it to be inside. You click reverse, and yes, it looks right. You click OK. So it seems that it offsetted also the other features. So if we let's go back for a second, click offset entities one more time, and deselect chain. Chain basically means that it's gonna also offset all the other sides of this closed sketch, and we don't want that. We only want this feature. So we click OK. And if you can see here now, if you zoom in, we can see that this line was offset, and but it did not account for the different length, so we have to trim that. Make sure you trim all these small lines because these lines will either make or break, your model. It can give you a lot of trouble. Oops, my bad. And I'll trim this line as well. And we'll have to trim like these two lines as well. And that line. And now we should have this feature in the sketch, and we can click OK. For the trim tool, we can go to features, we can go to extruded cut. And if we look over here, it tells us that this distance from this surface to this surface is 12. So we will use the same method what we did last time. We will click on the type of extruded cut we want. We want to offset from a surface, and we will select this surface, and we will offset that to be 12 as how the dimension has it on the document. So we click there, 12, click enter. And when we look at the preview, it looks correct because if you see here, this is on the same, like where it ends is the same coplanar to this feature. And if we look at the picture, that is correct. This plane, I guess, yeah, where we are extruded cutting is coplanar with this surface. So we click OK, and if we zoom out, we look, it looks similar to what we want, if not exact. If we scroll down, yeah, that's it. That's all we needed to do for this type of problem. And it says that we have to evaluate the whole overall mass of this part in grams. And if we look at if you go to the evaluate tab, we go to mass properties. We look at the mass, it says 432.58 grams. And I think that's correct. If you go down to the answer key, question number 6, it's 432.58 grams, which is exactly what we have. So if you got to this stage, then congratulations, you finished this problem or all the consecutive problems. To get this question right, you need to get all the first, 4 questions correct. So it might be challenging, and but with practicing, you can definitely do it. And what we did, all the tools that we used to make this model will be sufficient, if not, uh, will enable you to, take the exam and pass it with flying colors. And you just you have to know how to approach the problem once you have all the tools. And for this concludes all of the tools that we need to know for part modeling. And to move to the next step, we will be going over assembly modeling. And we're going to have usually 2 questions on the exam. And we're going to go over that now. And I will let Dan, the other CAD leader, take over.
All right, thanks, Basil. Let's go over the assembly modeling. I'll share my screen for you.
Yeah.
Okay. So yeah, great job on the part modeling. We shown a couple tools you can use to create all these parts to your liking. And we've done a couple examples. And now it's time to take those parts and see how we can put them into one big assembly of multiple parts. So you can see in part 3 of this exam, we'll have 2 questions on assembly modeling, and they'll actually be consisted of several different parts we need to put together. So let's go over how we can do that. So they should give you a zip file with all the parts you need. You save those parts and then you open them in SolidWorks. And you can create the assembly um, with respect to the origin as shown here. So it's important that you, if the question specifies, you create the correct orientation of the origin, and you'll see in a second how that looks. Then it'll give us some more constraints here. It tells us how to mate the different parts, which we'll go over. And it tells us some more information about our assembly. And finally, notice you're going to use another mass properties tab to check the center of mass of this part of this assembly. And then we'll just have to change our global variables and see the updated center of mass. So to create an assembly, you go into File, New, and instead of the usual part, we'll go right to Assembly here. Now you'll notice when it asks, or when you begin an assembly, it asks you which parts you would like to import. So I'm going to import the long pin first, and then we can add more parts as we go along. We don't have to import them all at the same time. So I'm going to import the green pin first. And by doing this, if I insert right here, we just have to check now if our origin of the entire assembly is aligned with the origin of this part right here. And it looks like those 2 points are at different positions. So I'm actually going to want to align those properly before continuing. I think there's 2 ways to do this. You can start the assembly by opening up this part and not adding it through that feature edition. Or once you've already added it, at this point, let's go ahead and just take these 2 origins, control left click on both of them, and we can actually go to our assembly tab and create our first mate. So the function of the mate is to position those 2 components in some way relative to one another. And there are many different types of mates. The one we're probably going to want to use here is a coincident mate. And we also want to align the axes. That'll put these 2 points right next to each other. Usually when you do this, the parts will automatically align each other. So I notice they're not moving, which means this part might be fixed. And it does, so if we exit the mate tree, if we right click on this one, we do see that it is fixed, and we can click float to make it freely move again. So now that I've done that, I can go back to mate. I'll go to my feature tree and click the origin of our assembly and also the origin of this part. And now they do move together and the axes are aligned. So I will click the check mark to add and finish my mate. And now it's a good idea to go back, right click, and fix that part once again, because now that ensures our assembly is not going to shift from that point. Okay, so we've got that, and looks like our axis on the bottom left here is the same as the axis shown in the assembly on the right. So we can go ahead and start putting in some of the other parts. One part I see here is the chain link. Let's go ahead and insert that component and select the chain link. You'll see it might not be aligned properly at first. That doesn't really matter. We can put it in any way we want because we will fix this with the mates afterwards. So making sure this component is fixed and this one is free to move. We will look at what it tells us here. It says that pins are mated concentric to chain link holes. So these two will be mated concentric. And pin end faces are coincident to chain link side faces. So that basically means we can start with mating these two pieces concentric. Let's mate the pin right here and the circle in this chain link and make those concentric. I think we can go ahead and we can probably lock that rotation. It looks like it's mated along the x-axis, and that is what is shown right here. If we don't lock the rotation, it might move around like so, and we don't really want that. So let's go ahead and go back to our mate, right click there and edit that feature. And we'll go back and make sure that we lock that rotation. So now it looks like it's going to be fixed along that x-axis. It can only slide up and down now, which is what we want. Okay. And the second condition here is that the pin end face is going to be coincident to the chain link side face. So if I go back to my mate feature, I can click the end of the pin here and the face of the chain link right here. Those are also coincident. And it looks like our mate alignment is correct here. So I'll just go ahead and check that off. And now if we try to move this piece, it tells us that it's fully defined. So that's good. It's not going to shift on us. Looks like we need to now add another small pin, a short pin actually. That will also not be perfectly aligned. If we want, we can use this little tree right here, this manager right here to shift it even before we start the mate. So I'm going to flip it along the x-axis by 90 degrees. That should make things a little bit nicer for us to mate it. So once again, we'll have a concentric mate between these two parts. And let's just go ahead and lock that rotation. And we also need the coincident mate on the faces. So I'm going to mate those two faces to be coincident. Now it should be fully defined. Okay, that's good. The next part is going to be another chain link. Let's go ahead and put that in. You could maybe rotate this about the y-axis and then against the z until it matches somewhat what it looks like on the right-hand side. Now, once again, we will mate concentric with this pin and this hole. And let's go ahead and we'll leave the rotation free for now because you could see we'll have a dimension that actually defines the angle of rotation. But we do need to make sure that these pin faces are coincident. So this right here, notice you don't have to go into the mate feature right away. You can click the two faces with left click and then shift left click. And then you can click mate. And I'm going to want those two faces to be coincident so that I'm only allowed to rotate now. Okay. So one thing we can do is instead of dimensioning now, we will actually create a mate to show this angle relationship. This is one that we haven't done before, but we'll make this face and this face. Initially, they'll look parallel, but what we can do is actually click this angle mate. And we could set this angle to whatever the value of A should be. It tells us that A is 25 degrees. Let's go ahead and see if we can set A equal to So, okay, well, we'll set that global variable later, but let's set that to 25 for now. Looks like it went the wrong direction, so we can flip the dimensions or the mate alignments until it matches. And it looks like this is the right combination right here. Okay, so now since I wasn't able to define the global variable there, let's go into insert, or let's see where we can edit some equations. So let's see. We should be able to, should be able to add some equations here that will relate the two components. Mm, Let me see real quick. Okay, so the equations should be under tools and equations. And we can define our global variables here. I'll set A as my first variable, and let's check what that was. That should be 25 degrees. So under value, we'll set it 25. We don't have to set it with the unit because we'll apply those units in the mate. It's kind of optional, but you can define it if you'd like. Okay, let's see. Let's go ahead and just define the value. And now our equations pop up right here. Okay, so let's see if that works. We'll go back to our angle feature. We'll edit this and we'll set it to our value A, which doesn't look like it updated. Okay, so let's go ahead and click that, double click on this dimension. And from here, we can definitely change it to be our global variable A. Once I type in A, you'll see it pops up right there. Let's make sure we set it equals to A in quotation marks. Now we can see that global variable pop up, that globe right there. And if we set the check mark, we'll see that this dimension actually updated to show that it is related by an equation. You can see the same symbol right there. So that should now update if we decide to change the equation. We can probably go ahead and just define the rest of our variables right now. Set B equal to 125 and C equal to 130. So those all pop up there, and we can continue building this assembly with another short pin. Put that right there. And again, we'll just be using the same mates where we make a concentric mate with that hole right there, lock its rotation, and a coincident mate with the two faces. So you can see it starts to get pretty quick once you practice all those mates. Let's go ahead and insert another chain. And we don't need to rotate or anything because once we click these two parts and mate them, they should align automatically. We just might want to, actually this should be fine because the part's symmetric. We can just rotate it out to the front. Yeah. So we leave the rotation to be free because we will define the angle with the global variable. Let's bring that out to the front. Let's make sure these two faces are actually coincident first. That should be all good. Now the other main dimension we want here is a relationship between these two. That is going to be another angle mate. So let's set the angle measure to B. And it looks like I'm having trouble entering it in here. It doesn't want me to enter it there. So we can actually set it to whatever. Then we can go back to the mate. And once we see that angle pop up, we can double click. And from here, we can set it equal to B. And it does show up with that global relation. Doesn't really look like it updated the part there. You can see it still looks the same, even though the angle changed. So what we can do is we can go ahead and press rebuild. And now it should look the right orientation. So really starting to come together here. We can add another set of components. I'm going to add another short pin right here. This will be mated concentric to this part inside here. We'll lock that rotation. And then we can mate these two faces, again, coincident. Now we just have two more components. There's a chain link that'll go right here. Again, we'll just mate with our standard concentric and coincident mates. And we'll have to add another angle mate and relate that with our global variable. So the angle is going to be, doesn't matter here, because we'll go back into here and we'll double click that dimension and set it equal to global variable C. And just rebuild that part. And finally, there's another long pin here. So we'll add that right there. We can go ahead and mate those parts. I'll lock it. It doesn't really matter if we lock that one or not, but we'll go ahead and do that and mate those two pieces coincident. So it looks pretty much like what we have in this picture right here, aside from some of the lighting. And we can verify the origin is where we want it with the right coordinate system. So after we've done that, we want to find the center of mass of the assembly, which again is going to be in the Evaluate tab and in Mass Properties. Center of mass is x equals 348.66, y negative 88.44, and z negative 91.40. That looks like it matches up exactly with this answer choice A. And the answer for 7 is going to be A. So you've got that one right. And this one right here, that's going to be it for question 7. You just have to create that assembly, make sure you got the mates correct, make sure you've got all those global variables and whatnot, the dimensions. And it's really simple to do the next question, number 8, as long as you've properly defined everything in your assembly. So all you have to do is use the same assembly that we just made, and we have to just modify these parameters. So I can go manage my equations. A will be 30, B should be 115, and C should be 135. It looks like it modified automatically, so we don't need to rebuild that. You can if you want to be safe. With the new center of mass in mass property is shifted a little bit to these new coordinates. Let's just verify that we've got that correct. So 327.67, negative 98.39, 102.91. So those all match. Okay, so you can see as long as you've defined everything properly, you can go into your equations and quickly edit that. That's the power of global variables. As for the assembly, you just have to make sure that your origins align, and you can do everything with these two buttons, insert components and mate. And those are going to be your best friends for this. You'll have, as long as you mate everything properly, then you should be good for the assembly modeling. Okay. So I think that's it for those questions, actually, for the exam. Basil, do you want to add anything?
Uh, no, that's it. We will basically went all over all of the topics that will be covered on the CSWA exam. Now, the only thing that we can do more is to practice more and get more proficient with using these tools and and solving these problems. So what I would advise to do is to practice more problems, try to find example exams and example problems online, and we will try to also provide some, but you can always find more online. And if this tool, SolidWorks and CAD in general, is a very useful tool, especially when you go into the workspace and you can get internship opportunities. You can boost your resumes with it. So I would definitely recommend that this is something that you should invest time in, especially now in the summer. You can definitely work more and try to, get really good with SolidWorks and hopefully take the CSWA exam. And we'll try to contact SolidWorks and try to get the exam for you guys to take for free. So be on the lookout for that. But uh, yes, this concludes our third workshop. I hope you guys liked it and you learned from these videos, recorded lecture videos, and yeah, I hope to see you guys next semester. Hopefully, if not gonna graduate, and we'll be in touch. And thank you for watching.
Yep. Thank you guys. All right.